Welcome to week 6, lecture 4. In this lecture, we will calculate confidence intervals for the population proportion. So far, we have been calculating confidence intervals for the mean of a continuous variable. However, in epidemiology, we are usually interested in binary variables, such as died, yes or no, disease, yes or no. In this session, we are going to calculate confidence intervals for a population proportion for a binary outcome. When the sample size is large, we can use the central limit theorem to approximate the binomial distribution to normal distribution. And the criteria for large sample is when n times p is greater than 5 or n times 1 minus p is greater than 5. This means, therefore, that the sampling probability distribution for a sample proportion is normal distribution, and we can use this standard normal distribution to calculate the 95% confidence interval for the population proportion. The formula for calculating the 95% confidence interval for the population proportion for large samples is given by p plus or minus 1.96 times standard error, where p is equals to sample proportion calculated from the sample data, and SE is equals to standard error, which is equals to square root of p times 1 minus p over n, where n is equals to sample size. In this slide, we consider an example for calculating 95% confidence interval for the proportion. And in this example, we have 6 out of 52 lung cancer patients achieving a 5-year survival. And we want to calculate the 95% confidence interval for the proportion surviving lung cancer. So for the criteria for large samples, it says NP should be greater than 5. In this case, N is 52 and P is 6 over 52. So 52 times 6 over 52 is actually 6, which is greater than 5. So we can use our formula in the previous slide, which says P plus or minus 1.96 times square root of P times 1 minus P over N. Our P is 6 over 52, which is 0.115. And to calculate 95% confidence interval for the population proportion of cancer patients having 5-year survival, we get 0.115 plus or minus 1.96 times square root of 0.115 times 1 minus 0.115 over 52, giving us 0.115 plus or minus 0.087, which is equals to 0.028 to 0.202, and we can interpret this by saying we are 95% confident that the true population proportion of cancer patients achieving 5-year survival lies between 0.028 to 0.202. We have come to the end of this lecture, and in summary, we looked at how to calculate the 95% confidence interval for the population proportion when the sample size is large. And remember, the criteria for sample size being large in a proportion set up is either NP is greater than 5 or N times 1 minus P is greater than 5. The formula for calculating 95% confidence interval for the population proportion is given in this slide, which is sample proportion plus or minus 1.96 times standard error, which is given by square root of P times 1 minus P over N. The P is the sample proportion that is calculated from the sample, and the 1.96 is from the standard normal tables. We can also use theta to calculate 95% confidence intervals, and for more information you can read chapter 14 of the prescribed textbook. For any questions, You can email me at alfred.msekiwa@up.ac.za. Thank you.